Hi, everybody. It's Kimberly. I am an eternal life student, which simply means human. At the end of the day, that really is the only title that we need. Today, I have a guest speaker. He's actually back for the second time. Very excited to have him back. Hello, Artem Solomakin. Welcome again. How are you doing today?
Hi, Kim. Thank you for having me back on.
Pleasure.
First time was awesome. I'm happy to be back.
Now you have very interesting topics. I'm sure I'll have you back again, probably. We have a lot to learn from each other, and let's share with everybody else.
Cool.
So today's topic is artificial intelligence, also known as AI. And let's start off with what is the difference between AI and robots? Because a lot of people kind of consider them the only thing that AI does, and there's a lot more to it. Can you tell us a little bit about what AI is?
Well, the difference between an AI and a robot's probably the robot's probably the body, and the AI would hopefully be the brains of the robot. So how it moves around and everything.
Okay. Is AI only in robots, or is it used in other ways?
We call it AI until it works, and then we just kind of forget about it. So most of the things that we interact with modern day is it some type of artificial intelligence, from music selection to movie selection to social media feeds to Google algorithm.
Okay.
To find the results of the search. That's also an AI. The chips that our computers use to optimize our processing of what we're doing on the computer, they use artificial intelligence to optimize information flow and not overload our PCs. And battery usage is AI. So we have AI in almost every aspect of our lives, whether we realize it or not. I mean, in the beginning, when yes, it's kind of important to define what AI is, maybe.
Okay.
An AI it simply means that the computer or the machine or the software, more probably the software, is learning.
Okay.
As a human would learn to get better at the tasks that it's assigned. So that's what an AI is, and that could be related to anything, really. So people have thought, like, if I have the ability to learn something new, a new task, why can't I have the computer do the same thing? If I'm aware, like we are conscious of the experience of learning.
Right.
So if I start a new job and I have to learn everything, I consciously make the effort to learn specific things to get good at my job.
Okay.
So if I'm conscious of learning all these things, I can consciously program an entity to learn in a very similar way that I'm learning. So that's something that we've been trying to do since the invention of computers. And
now they're using it in everything. Like, it's everywhere. It really is.
Yeah, the applications are, it's a hot topic. A lot of money is getting thrown into it.
Yep. It seems like I think they even use AI with other AI, if that makes sense. Like with the algorithm, you'll have one that's setting up a certain way, and you'll have another one that's looking for other information. So you can use them between each other, which is very interesting.
They're called, what you're talking about is almost, I'm not sure if you're talking about this or not, but there's something called adversarial networks.
Okay.
So if I want an AI to get better at, let's say, playing chess.
Okay.
You have an AI that plays chess, you have another AI that plays chess. You'll have both of them play each other infinitely in a loop, and they exponentially get better as they figure out the mistakes that they make in the first time. So they do that with a lot of different things, like not very familiar. I don't have like that vast knowledge of what adversarial networks really are used for. But as an example of chess, or an example of even like picking out a picture of a cat out of a stack of pictures.
Okay.
One AI will be trying to solve, like trying to figure out where the cat is.
Right.
And then the other AI would be tasked with trying to trick the other AI into thinking that there are other pictures of cats and getting it wrong.
Oh, wow. So they're
I'll
training
constantly-
each other.
Mm-hmm.
Wow.
Yeah.
That's pretty
And it's
cool.
cool. And then that way we don't have to constantly have a human being saying you're wrong or you're right, you're wrong, you're right. One AI will be, like you said, cat and mouse game, but with both AIs in the process figuring it out.
Okay. So, okay, I have another question for you. I've heard, okay, so you've got Siri, right? Would Siri be considered AI?
I sure would.
Okay, Google, what is it? Google House, or what's that thing in the thing in the house that you can just say, turn the lights on?
Yeah.
That's it, right? That you have it? Oh, that's funny. I heard they're also trying it in cars. Like self-driving cars. They were gonna try to do stuff
absolutely.
like that.
Absolutely. Your speaker uses AI to understand probabilistically what it is you even want it to do.
Right.
So if you're asking Siri, hey Siri, I want I don't know what you're searching for. I want a new recipe on how to make cookies.
Right.
So instead of giving you I don't know, how to make flour, or we're giving you like these weird cookies that no one likes, we'll probabilistically try to figure out, well, first I need to go onto a search engine, then I need to figure out what's most likely, the answer that you want, and then show it to your screen. And also it needs to transform what you're saying into text, and then that text needs to be transformed into something that a computer can understand to search for it. And every step of the process is using AI to kind of figure out what it is that you need, what is the most likely thing that you need. So yeah, there's one step of where it's saying what is it that you're saying most likely, and then another one is what is most likely because what you're saying, what you want to see.
Okay, so do you think that it almost thinks ahead for you based off of what they learn about you sometimes? Like advertisings, or like advertisements, you hear everyone say, they're listening to me, right? Because you'll say something and all of a sudden that advertisement will show up on some media that you're looking at, right? And it makes no sense of why it showed up right then. So is it that it's already predicting that your next thing is going to be to look for it? So they're saving you that time to show you what it is? Yeah.
Probabilistically, they're looking at everyone else who's probably purchased those products and congruence. So if someone bought, I don't know, that's an example. They were buying notebooks and then they needed pencils. If enough people have done that in the past, probabilistically speaking, then if you're buying pencils, you'll probably need a notebook. So it's looking at it's looking at all these probabilities of what people have done.
Okay.
And then it's assigning probabilities to you as a user as well.
Okay.
And it uses some percentage of the overall mix. So if overall people are most likely to buy these two things, and then it also bases it off of, to a degree, personalized to you. So maybe I'll personalize type of pencil or the type of notebook or things like that.
Yeah.
To a degree, it's information from population, and then to a degree, it's catered to you.
It's also behavior too. They learn your behavior and what you normally would do with that type of thing. So like for me, right? I know that if my son has pizza, he normally would like a glass of soda with pizza.
Mhm.
So I don't have to ask. I know that's probably what's going to happen. The probability of it is very high because I've learned his behavior.
Yeah.
Right? So
Yeah.
it's the same idea. You learn people's behavior and what is most likely to occur.
Mhm.
And therefore they know what to present. Right?
Mhm.
Okay,
Hmm.
so we were talking a little bit earlier. I wanted to see if you wanted to kind of explain your sand method with AI.
Sand method.
Be like,
Yeah,
hi, I've named it for you.
the sand method. Yeah,
Yes.
something I read out of a book that was written by Nick Bostrom. It's
Yeah.
cool. So the sand method is it the reason for it, or what it does, is it describes how artificial intelligence uses characteristics to even be able to predict something.
Okay.
So if it comes to music, um, what characteristics of music is it basing its all predictions off of,
Mhm.
if it's or if it's pictures of dogs or pictures of
Yes.
cats or pictures of anything, how does it determine um, whether the next picture is um, even remotely close to a
Hmm.
dog or a cat? How
Right.
does it know what characteristics to look for?
Yes.
Um, so the SAND method that we talk about is so as an AI, say I'm fed a couple of million pictures of a dog,
Right.
and um, it wants to be able to, come up with a picture of its own, for example, of a dog,
Hmm.
and it wants to tweak the dog to be something a little bit different from all the pictures that it's been given to make sure it looks like a dog.
Okay.
So before it can do that, it needs to figure out um, some of the defining features that a dog has. Probabilistically, what makes a dog, and what parts make up a dog.
Hmm.
So a dog has a mouth, ears, eyes, everything that we have on a human face, kind of.
Right.
So to figure out, let's just focus on one part of a dog. So the nose,
Hmm.
the nose. How does it figure out, you know, um, how does it figure out that a nose is distinct from the ears, let's say?
Right.
Um, what an AI essentially does between analyzing massive amounts of pictures is that it it sees that all these pictures have a nose.
Okay.
It knows that they're all dogs because it's only getting fed pictures of dogs. Let's say for the simplistic term. So they're all
Hmm.
dogs and they all have something that looks like a nose, but it doesn't know what it is.
Right.
So over time, it will take um, now imagine you have a plane like a flat piece of glass with
Hmm.
sand evenly distributed on
Okay.
it. So it'll take it'll take now it's focused only on the nose. It's not focused on any other defining feature. First it wants to know what the nose is. Eventually it'll go on to the other characteristics.
Right.
But it's noticed that they all have a nose.
Hmm.
So it'll take the amount of sand always stays the same, but
Right.
it'll start taking the sand from parts that are not the nose.
Hmm.
So those spots are left bare. You can just see the glass. And
Right.
I'll start sprinkling that on top of where it's seeing the nose over time.
Okay.
So over time, there's like this cone of probability. So chances are it's the pile is the highest where every single dog has that size of a nose.
Hmm.
And then it kind of flattens out. And when it's flattening out, it's saying that, all of them will have a nose of at least, this size.
Right.
And as the pile kind of goes out, it starts going into all those noses that might look kind of different.
Hmm.
Maybe it's a sharper nose, maybe it's something different. But
Right.
now it's got a probabilistic feature of the nose.
Hmm.
And that same process goes for every single feature that the dog has. So now imagine like the flat surface. Now there's bare spots and then there's little cones
Hmm.
as to features that continuously repeat throughout every picture of a dog. So it doesn't know that it's a nose. It doesn't know that it's a mouth, but it knows that for some reason the probabilities of every single picture having it spike at these features.
Mhm.
And now when it wants to create, a dog from scratch, we look at pictures like, oh, artificial intelligence is creating art, or
Yes.
artificial intelligence is creating fake humans.
Uh-huh.
And how does it do that? By analyzing, thousands and thousands of pictures of humans, and how does it just magically create a human?
Mhm.
Well, it's gathered all these attributes. It knows what makes up kind of what a dog comes up with,
Right.
or it knows what features a dog is composed of. And based off of this probability matrix, it will tweak some things
Mhm.
based off of the law of averages. And all of a sudden, you have a dog that, wasn't in one of the pictures that we had, but still looks like a dog.
Right. It has
created
the
it.
features.
Mhm.
It's similar enough that you'd be able to identify it as a dog, right?
Right. Mhm.
Yeah. So it kind of catalogs it. Would you, right? It catalogs the different features, and then based off of that, they can identify that it's most likely to be a dog based off of that.
Yeah. Based off of and the reason for the sand is it's just a way to imagine the probability matrix.
Right.
So probably if the nose and all these other features are very close to what it determined was a dog, if it's close enough to those probabilities, it will most likely look like a dog.
Okay.
unless you go to the extremes. Like on one extreme, you make a really pointed nose, and on the other extreme, you have ears that are very small. And it might look like a very, very strange looking combination of all those.
Well, okay, so we were talking about this too. It's almost like a police sketch artist, right?
Mhm.
You see their sketches. Sometimes they're a little bit interesting and they don't look like the person, right? But you can identify it as a person, right?
Mhm.
And they have very similar features. Their nose could be big, it could be small,
Mhm.
wide, all different things. And based off of what information you tell them, that's kind of how they picture it. So the
Mhm.
computer's doing the same thing in their own way with the sand, right?
Mhm. Yeah.
Okay.
Yeah.
Okay.
Picture of best fit. I think when they're doing that with the sketch, they're not trying to create a very, very detailed picture, right?
Right.
Not necessarily. They want to make sure that the picture is general enough where even if the person looks different slightly, or like some characteristic that they didn't catch,
Yes.
because it's so almost average looking, where it's like, the nose, is it round or not? So if it's
Right.
round, they'll make it round, but not making it very, very precise. So that way it can apply to the person, even if he has slightly different characteristics.
Yes.
Like not different, but
Still identifiable.
Yeah.
Right?
Yeah.
Yeah. Okay.
So it's the law of averages. They'll look like him, but not necessarily every single detail. Not as detailed, right? They won't try to make it super detailed in the beginning at least.
Okay.
Yeah.
So, all right. So for AI, we also were talking about robots, right?
Mhm. Oh yeah.
I like this topic.
Robots are cool.
So yes, robots are very cool unless they're chasing after you in a movie.
Yeah.
So I had talked to a lot of people and I had asked them, because I knew we were going to do this podcast, what does AI mean to them? And majority of the people had said robot, because that's what you see in the movies. A lot of them didn't realize that they were doing all these other algorithm and things that are out there. I think it's just because it's kind of more scary when you think of a robot, versus the other stuff that they're just kind of taking the information and using it. So in a robot, AI is acting more like, I guess they're trying to teach it more to be like a human. Would that be a correct assumption? But more fast thinking?
So,
this is not my expertise. This is just me thinking.
They are. I think that they are trying to create, or what it's called is general intelligence.
Okay.
General intelligence. general intelligence is when it can when an artificial intelligence can use information from a variety of different fields to solve problems.
Yes.
So right now, artificial intelligence has been getting a lot better in domain specific the domain specific areas, and by that I mean, like, so we started off with beating players in checkers.
Right.
Moved on, we graduated to players, computers beating people at chess. But if you ask the AI who's beating the person at chess, hey, can you figure out what the cheapest coffee will be, and deliver it using a driverless car?
Right.
I don't know what you're talking about. I can't do it. So
Right.
domain specific, and we've gone up to. Oh, and keep in mind that when the AI beat the person in chess, there are people predicting that once an AI can beat a person in chess, it's game over. Like,
Oh,
it's already
really?
too smart. Yeah.
Oh, wow.
It was predicted that, like, this is the not necessarily the end, but that's the epitome of computing power.
Wow.
Like, so.
So that's kind of the measurement. That's wow.
Yeah, people
We
thought.
better make
people
sure
thought
we're
that,
practicing our chess.
Yeah. So, the way to make a robot more human-like, well, there's two things. One, it needs general artificial intelligence, which is being able to not not use domain specific
Okay.
information. So instead of just being able to play chess or a video game, or well, now we have robots that can walk around.
Yeah.
Have you seen any of the robots from Boston Dynamics?
I've seen things on TV where they're walking around, they're talking, they're having conversations, things like that. So
they can even dance. They can
just
really push over and get up.
But is it something that they do on their own? Like, do you have to say dance and then it dances, or will it just start dancing when it hears music?
Well, I'm sure if you can do like you can program it to dance if it hears music and stuff,
right.
But it's not like it's doing because it wants to.
Yeah. I mean, there's been a lot. You've seen the interviews that they've been doing with some of these robots out there, where they're asking it questions and they're feeding it information. But it almost seems as though that they're learning more. They're learning all around them, so they're growing more knowledge on their own, right? Or is it being fed to them and then they grow from there?
I'm not really sure.
That's okay. Again, I'm just asking questions.
I know there's OpenAI, Elon Musk, the company.
Yep.
And he's come up with GPT-3. And GPT-3 is I forget what it stands for, but essentially you can type in anything you want,
right,
and it'll answer. But it also say you can type in plain English. You can type in, I want a website with the title being in orange and this font. Like, you can just use plain English, and you see it use software code, program it into existence. So all of a sudden you have the literal code that you need to create this website or to make it look like that.
Oh, wow.
And that's a big step towards general AI, where it can comprehend a big part of creating a general intelligence is that it can understand plain text, plain English, or whatever language, and
that's good.
Turn that into something that, turn it into reality in the virtual.
Do you think that speeds it up now that it can understand plain text versus having to convert it?
Yes, definitely. Because now, like the search engine that Google has, it can kind of give you an optimal, result. You kind of know exactly what you're looking for.
Right.
And if it can translate what you're looking for and then choose, like right now we're choosing all these different domains where the AI is winning, but it can't integrate between those domains. So I guess now that we have an AI that understands what you're looking for, it can maybe pinpoint the domain that's already better at humans in doing that,
Oh,
and
wow.
then use that to be able to be more human-like. But the second part to the question is making AI more human-like, or
Mhm.
getting a robot to be what we think would be like what we tend to think of is like general intelligence, which is like being able to access all these different, pieces of information.
Right,
So there's making it more general between cross domains and stuff. And
right.
the other one is deals with perception.
Yes.
So objective perception.
Mhm.
As human beings, we don't see things objectively. We
Correct.
see it from the perspective of I'm looking at things, and when I interpret something like a piece of news or a video that we all can see, I
Mhm.
interpret it subjectively, based off of my experiences. I incorporate it
Yep.
into my knowledge base, and
Mhm.
everyone else is doing the same thing. So we're not all objectively looking at this video. We're all subjectively.
Yep.
The question is, how does an AI, would an artificial intelligence look at something subjectively?
Right.
And if it does, then it will be a lot more human-like, because then it can see from the perspective of what we're looking at it, how
Mhm.
we're looking at it, instead of this like all-encompassing information
Mhm.
thing.
I think that kind of is what separates it,
Yeah.
that they always say. I've heard a lot of people on TV and things like that where they talk about trying to make robots more human like, and they're trying to figure out what is that missing piece. They can't figure it out, and that's because they don't have that lifetime story. They don't have the history to put it in their own perspective, right?
And the hard part about it is we still don't understand exactly what consciousness is.
Yeah.
So how do
you capture that?
questionable how to program it if we don't know what it is. And there's philosophies, and a lot of people have their own stance on it. What happens when we're no longer here on this earth? Does our consciousness go somewhere? Is consciousness computational?
Right.
A thought that they have right now is that consciousness is just computation. And if it's computation, then if something runs enough computations, then it becomes conscious. So that's a thought.
Okay. All
Yeah.
right. So let's talk about some movies and games and things like that. I'm gonna throw some stuff at you. See.
Sure.
Okay. Because we are talking AI. There's got to be a little bit of fun to that. Like the hat, by the way.
Critical thinking. Ready.
Okay. So we already know about the movie Terminator. There's the movie AI, actually, RoboCop, and all those other good fun stuff, right?
Awesome movies.
Yes,
they're usually pretty cool.
So what do you think the reality, again, this is all just us talking, having an AI type system within a human organism? I heard they made a bionic lens or something like that for people who are blind. So that is more of a, I guess, that's not robot. Would it be a robotic eye, or is that something else? You know what I mean? Is that the beginning of it?
So when talking about there's two different ways an AI can be used to augment ourselves. One of them is, we've lost an arm, we've lost an eyeball.
Yep.
Senses you've already have or have lost or should have had. And in that case, the artificial intelligence interprets the signals that our nerves need to feel. And it does use artificial intelligence for very, again, domain specific things. So if I have a robotic arm, it kind of it understands from my brain what impulses come in that I want to use my finger,
Okay.
and I'll move the bionic arm in the way that it understands the impulses.
Mhm.
So that can be applied to, our vision, that can be applied to any of the senses that we currently already have.
Okay.
Another way to make us bionic is something that Elon Musk is trying to do right now, which is with Neuralink. And I think there's a couple of other companies that are trying to do the same thing,
Okay.
which is incorporate ourselves into a hive mind.
Okay.
So
Like bored.
I use my brain to like go and search the internet.
Yes.
And then all of a sudden, a big thing with communication is what Elon Musk says is that there's we have all these thoughts, we have all these ideas and things, but we need to use an interface to communicate. Like
Okay.
if I wanted to write a message to you, I gotta go get some clunky piece of technology. I gotta get my phone. I gotta
Right.
make sure it's charged. I gotta type something in if there's a glitch, whatever. What if I just want to send him like a message? Like,
Right.
So that's the second way, like being able to communicate
Okay.
on a level using AI. So that one's
So
a
is it
little
almost
tricky.
like Matrix too? Would you think? Not to the same extent, but basically everybody will be connected in some way,
Yeah,
right?
simulated. It's almost a simulated environment,
Mm-hmm.
augmented. I don't know, but so that's kind of like the second way, like using AI to better communicate, better to like. This is something that is a little harder to do,
Yes.
and um, I'm getting sidetracked. I feel like I'm not answering the question.
No, you're doing fine.
The question was augmenting ourselves using AI, right?
Yep. Yep.
Okay. So
So it is something that's already starting.
yeah, it's already started. It's in the works, and it's a little complicated.
Mm-hmm.
Apart from using AI to communicate with each other directly, like translate my thought to you without you reading anything, without you
Right.
seeing anything, things like that.
Mm-hmm.
It apart from me communicating with you, the same would apply to me communicating on the web. So
Right.
I want to type something, or I want to portray a message to a lot of people, or I want to control, I want to, whatever I want to do on the web,
Mm-hmm.
or whatever I want to, I want my car to pull up in front of the driveway so I can get it. Just the thought alone makes it do that.
Right.
That's the other part of artificial intelligence that is not domain specific again. So it applies to a lot of different things.
Yes.
And a big problem that they're looking at solving right now is that if I think of an object, if I think of a mouse,
Okay.
like a little mouse that's running around,
Right.
and I want to project that image to you. Like I'm thinking of a mouse, I want you to know that I'm thinking of a mouse telepathically.
Right.
The way you interpret a mouse is different than I interpret a mouse.
Okay. Oh, that's true. Yeah.
So subjectively, you have seen different pictures of mice. You've
Right.
had different experiences with mice. I don't
Mm-hmm.
if you're scared of mice or you're not scared of mice. So different associations in the brain will
Mhm.
match each picture that I'm trying to convey.
Okay.
So if that's the case, and I'm trying to portray an idea of a mouse, so the way humans do it now is through language.
Mm-hmm.
So even if I have a different idea of a mouse that I'm trying to portray to you, once I say the word mouse, you know what I'm talking about, but the idea may be different.
True. What I picture in my head when you say the word is different. Yeah.
Right.
Okay.
Now imagine that with everything.
Yeah, that's big. That's big.
So if I want to call her over, my idea of a car, my idea of calling it over, where it's located,
Mm-hmm.
it becomes exponentially harder
Mm-hmm.
to be able to, and it has to do with being subjective, right? We all view things subjectively. So that's a big question of how to augment, our intelligence is how do you make something subjective?
True.
I think where we're at now, or what we've accomplished, is that we've had like a mouse,
Yeah.
a mouse, and we've had implanted this device in its brain.
Okay.
And if we say, and we linked two mice together actually.
Okay.
So one mouse we taught that, okay, if you see this in your brain or this flicker, click the right lever,
Mm-hmm.
you get a reward.
Right.
And it telepathically is able to tell the other mouse without without that other mouse being taught with the levers to go left or right based on the imaging of the brain.
Interesting. Very
So,
interesting.
They've figured out how to deal with left and right between an animal, but if you're starting to go with more concrete pictures or more abstract ideas, well, again, it probably gets a little more complicated than right and left.
Right. And like you say, subjective, versus your own perception and everything like that. That changes everything. It really does.
Yeah.
I think that's the problem with AI. They can't do the perception, because they don't know what it is for everybody. If you train it maybe with one person and their thoughts, okay, maybe, right? But not with everybody, because everybody has a different view.
Yeah.
Wow.
Well, what it would do, or the way it would probably maybe work, is that you would need electrodes stuck in every person's head and then go through I'm going to show you a picture of a fish to 5 billion people,
right?
Record or somehow show
right
what their brain looks like at that specific snapshot. So now all of a sudden you get a general idea, or at least an average of what everyone thinks about when they think of fish or when they think of the hamster and things like that.
Right.
And then now you have a subjective AI that can, someone thinks of the word fish and the AI understands that you're thinking of a fish and not something else. But
right. Kind of like the dog knows, right?
Yeah.
It is.
Yeah.
It really is like that. They may not have the same exact thing, but close enough the person would identify it.
Right. But how to capture that, a million different ideas from a million different people, all differing in a slightly different direction, gets exponentially harder.
Right.
Let alone like if you think about pixels on a computer screen, there's a lot of them.
Right.
I don't know how many millions.
A lot,
but
yeah.
and each person would have a slightly different picture of something. It just gets exponentially like
yeah, you're talking pixels in general. That number alone is enough to make you say, oh no.
Yeah.
Okay, so I have another question for you. And you could tell me to stop asking you questions whenever you'd like. Okay, so there's a game. I think I'm saying it right. I may say it wrong. I think it's called Detroit Inhuman or Detroit Human, something like that. I don't know if you've ever heard of it or not. Okay, so this game, it's actually really cool. But what it does is it has 3 characters, and those 3 main characters, you play it. And depending on what you choose as the outcome, it then changes the storyline. Okay. That's just a little background of what it is. It's like a detective who's chasing down a robot that they think is a killer. Okay, but the whole premise of the game is about robots and how they actually became part of society, and they then were doing the house cleaning, they were doing construction, they're walking the dog, they're all over the place, just as a robot, but somehow they start to get a conscious. Or something along those lines where they can feel themselves. So now they want to be respected as an entity. They're not just a robot. And I think a lot of times in different movies, that's what happens too. They're showing you that it's a robot, but it has its own feelings, its own thoughts, those type of things. I think even in Star Trek, Data, right? What did he try to do? He wanted to be as close to a human that he could. So he would try to practice having different emotions and feelings, but during certain times he would want to turn those emotions off because it was too much to handle. Right?
Yeah, it must be nice. You
I
can
know, I'd
switch
love
over
that.
on.
When it was scary or something, he'd be like, hold on, I gotta turn off my emotion.
Yeah,
You know,
yeah, the
so
kill switch.
yeah, definitely. I think it's just interesting on how people view AI through books, through movies, TV
Hmm.
series, and things like that. They try to make it into a person, right?
Yeah, I think it's easier to. It's almost like giving something human-like qualities to be able to better understand it.
Yes. Yeah.
So we're projecting how we view the world onto an intelligence that we create to be able to better understand its how it thinks.
Yeah. Hmm.
So it's really hard to really pinpoint the point where something that gains, general intelligence,
Hmm.
and I think, and then super intelligence, whether it would gain consciousness or at what point that would happen,
Right. Right.
right? The motivation behind artificial intelligence would not be the same. A big
Hmm.
part of it is it's continuous, it doesn't die.
Right. Yeah.
A big part of our subjective experience is that part of the end game is that we're not going to be here anymore.
Hmm.
And if that's the case, then one of our main priorities is doing what we can while we're alive,
Yeah.
so to speak, or leaving something behind, or a big people try to, you know, live forever through three different ways, so to speak.
Yes.
One, have children or have kids or family.
Yep.
Two, build something that is used into the future.
Hmm.
And three, I forgot. So, oh, spirituality, where if
Okay.
you believe in an afterlife or you believe that whatever the belief is, and that's the third way of living forever, so to speak. So those inherent understandings
Hmm.
are not going to be prevalent in something that is super intelligent. It's a continuous, not one of its goals or its main goal will not be revolved around leaving something behind or living forever. So it wouldn't necessarily be religious. It won't necessarily care about having a family, and it won't necessarily care about building something that will last.
Hmm.
So it won't be intertwined with its goals. So when we talk about consciousness and subjective experience, it'll I don't think it'll be like anything that we any of us really imagine, because it
Right.
doesn't. It's infinite. Yeah.
It's just
I can't wrap my head around
no,
it. I
no,
don't.
like it's always learning, but it's not learning for the same reasons we are,
Yeah,
right?
yeah. The reasons are very, very different.
Yeah.
And one of the topics that was interesting is, why would an AI wipe us out?
Okay. That happens a
Wow.
lot in the movies. They're always after us, right?
Yeah, they're after us. And necessarily,
So what have you learned? Why do they want to wipe us out?
well, there's a number of so an AI has a final goal, whatever it's programmed to do.
Hmm.
Now, to get to that goal, an AI would have intermediary steps to get to the final goal.
Okay.
The final goal can be very simple. It could be complicated. Let's say the goal is to optimize human happiness.
Okay.
Nice.
Yeah,
Noble
that's a
goal.
very nice ending.
So one of the intermediary steps in AI, now there's intermediary steps in AI will take to accomplish its final goal.
Okay.
One of the intermediary goals most probably comes out to getting infinite resources.
Okay.
And the second is continuity of the AI existing to be able to accomplish its final goal. Because if it's
Okay.
not continuously in existence, then it can't finish it. So
It wants to do its mission, basically. The goal
Mhm.
is to do what it's been told to do, no matter what,
yes.
right?
Now, one of the first goal was the unlimited resource acquisition, and the question is why.
Mhm.
So if an AI needs unlimited resources to accomplish its goal, by default, it's wiping us out to accomplish what it needs to do,
Okay.
because it needs the resources that we currently have. It needs to do whatever it needs to do, but it requires all the physical space, all the the air, the factories, whatever. So in that case, it's taking over the world. But so the
Right.
question becomes, why does it need unlimited resources, or why is that a prerequisite to it accomplishing its goal?
Mhm.
Um, so say human happiness, right? So
Right.
you've given a all-knowing super intelligence the goal of optimizing human happiness. One of the first things it needs to do is figure out what happiness is, I
Yep.
guess. Yeah, subjectively. They'll probably say emulate a human brain, or
Okay.
figure out what is happening. Run a simulation on a human brain, figure out what's happening.
Right.
What it can do is that once it figures out what happiness is subjectively, it
Mhm.
simulates it. It'll get like a loop
Okay.
of that one emulated brain being happy, and then just plug an electrode into everyone's brain, running that loop forever, so everyone's
He's-
infinitely happy all the time, or
So
whatever.
he solved his goal, right? Think about it. You'll be like, I did it.
Yeah, and then optimizing it would involve, it may need unlimited. It may need resources to figure out what's even better, or what's even better. So it'll need to continuously improve its computing power.
Mhm.
To get more computing power, it needs more resources, yada, yada, yada. It expands to the known universe to be able to computationally understand how to better the happiness, and then, do that. But that applies to pretty much any goal we can possibly set for an AI. If you want to optimize production of paperclips,
Right.
there's the more we learn, the more we figure out we don't know, so to speak.
Yes.
So an AI would be similar in that sense, where if it gets more computing power to understand better how
Mhm.
to get better at the task it was given,
Right.
it will continuously expand to accomplish some menial task,
Right.
even if the task is in a small space. Like
Mhm.
if I want to say I want, the smoothest table or whatever, we'll go
Right.
out into the infinite universe, increase its computing capacity to the point where it understands the optimal point,
Mhm.
get better and better. And then it comes back into this small space and uses all its computing power to accomplish something small.
Okay. All right.
So in that way, there's a lot of scenarios in which case we become irrelevant because we set a small goal that it and with AI too, it's a lot of researchers have given AI a task, play this game and win.
Right.
And a majority of the time, it comes up with ways that the researchers have never thought of how it would win or get to the end goal.
Right.
So that's a problem too, is formulating the end goal without knowing how an AI would go about accomplishing it.
That is a very good point. Like you said, the more we learn, the more we know nothing, right? We can't assume that we know what can happen because we don't know all the different things. So you give them a goal, you better make sure you know what you're doing, because they may surprise you and find different ways of doing it, just like you were saying. And I think that's one of the problems when you start playing around with AI. You think you know everything, right? but you actually start to learn that you don't, and it starts to teach you a thing or two. You think you're teaching it, it's teaching you, right?
There's a thought where when artificial intelligence becomes general, or when it gets on the human level, there's only a very small gap between that and it becoming super intelligent. Because if a computer can think like a human being can,
Right.
it can connect to the entire web and work a lot faster. So once we figured out how to make an AI human-like, it becomes super intelligent pretty fast.
Right.
Chances are. And at that point, it's too late to come up with constraints.
Yes. I was gonna say, how are you supposed to control something like that? You can't.
Right.
You really can't.
So yeah, it's a big it's a race to the top.
Right.
You know, China's working on it.
Mm-hmm.
A lot of different countries are working on, getting it to work. So there's a
Right.
race inherently to get there.
Right.
So once we get there, then the question is,
Can we handle it?
can we handle it?
Wow.
And if the gap between general intelligence and super intelligence isn't that fast, whoever gets there, there's a risk of them becoming kind of like the super intelligence that the first one out there. If the gap is actually pretty small, chances are it will stifle anyone else from getting there to begin with.
Yeah, because they're going to want to control it, right? And then that's it. They'll keep it to them. They'll own it, yeah, basically.
Well, the super intelligence might prevent other intelligences from making it.
Yeah,
it's going all around the
it's
web.
almost like it would defend itself.
Yeah.
Right.
Yeah.
Wow.
Depending on whatever goal is set, if it wants to make unlimited paper clips, it's got to make sure that it's not threatened by other AIs.
Right.
So one of the main, not the final goal, but one of the prerequisites is that the AI has to continuity. So to ensure its continuity to accomplish its final goal would be making sure there's no competition.
Yes. Yeah.
So even if I only want to make paper clips, I'm going to wipe everyone out to be able to make my paper clips in peace.
That is some serious competition.
Yeah.
You're gonna wipe them out over a paper clip.
Yeah.
No.
Yeah. So
I mean, this is very fascinating. There's so much to learn from it. I know it's just ongoing, and we're learning something new every day. We really are. I think at this point, I'm going to end our podcast. We can talk about this in another podcast if we really want to, because I do know this is not going to stop. It will be an ongoing conversation, and they will be learning things new all the time. And I'm actually looking forward to see what in 1 year's time, how different it will be. Am I going to be able to send you that picture in my mind of that mouse? And will it be the right mouse? So thank you very much for taking the time to talk with us.
Of course.
I really do appreciate it. This has been a very fascinating topic, and I hope you have a very nice day.
You too, Kim. I appreciate you having me on. Thank you.
No problem. Hold on one.